In question 2, we have to solve the inequality x minus 3 is less than 3x minus 4. Now, as there's a model sign involved, we can first whole square both the sides. So we'll get x minus 3 whole squared is less than 3x minus 4. Expanding, we'll get x square minus 6x plus 9 is less than, and this will become 9x square minus 24x plus 16. Now simplifying, we'll bring the left hand side on the right hand side. So this will become 8x square minus 24 plus 6, that becomes minus 18x, and 16 minus 9, that will become a plus 7 is greater than 0. Now factorizing it, we'll get 8x square minus 14x minus 4x plus 7 is greater than 0. And taking 2x common, we'll get 4x minus 7. And taking 1 common, we'll again get 4x minus 7 is greater than 0. So our values will be 2x minus 1 and 4x minus 7 is, so this is greater than 0. Now using a quadratic curve to understand how to give this as an inequality, we will write this as, so x will be 7 upon 4 and x is 1 upon 2. And it is greater than 0, so we need values which are above the x-axis. So what we will think is that the answer will be x is greater than 7 upon 4 and x should be less than 1 upon 2. However, there's one thing we'll have to be very careful about, and that is that from this equation, what we know is that this modulus sign means that this x minus 3 is always positive, which means that 3x minus 4 is always greater than 0, as it is a model sign, which means that this value is always positive, and if it is less than 3x minus 4, it means that 3x minus 4 should also be greater than 0, which means that the value of x that we will be getting should be at least be greater than 4 upon 3. Now, as x is less than 1 upon 2 does not lie in this domain, so our only answer in this case should be x is greater than 7 upon 4.